Okay, now we have a presentation on polynomials. Here. Okay. Mono means 1. Bi means 2. Tri means 3. A monomial has one term. A monomial has one term. A binomial has two terms. A trinomial has 3 terms. Poly means many, many terms. Monomials, binomials, and trinomials are all included as polynomials as well as any other number of items. This is the general form for a polynomial in one variable. These are the constants here. Just fixed numbers, they are called coefficients. The highest power of any x in the polynomial is called the degree of the polynomial. What this tells us is the overriding behavior of the graph of that polynomial. In the green here, you can see that that is the degree of the polynomial. So this one is going to be overriding. What happens is that when you look at this, it's the highest. So that means it's going to grow the fastest and it's going to dominate the other terms in the polynomial. The coefficient here with the highest powered x term is called the leading coefficient. Coefficients are here. Since addition is commutative, you can reorder the terms in a polynomial. Typically, we like them in descending order, which means that the highest power of x term first and then the next highest and so on. Variables raised to the same power are called like terms. To add two polynomials together, we combine the like terms. So with like terms, you have the same variable, same base raised to the same power, really. So here you have x terms. Okay. Like terms, same base raised to the same power. You see that? Those are like terms. At the same base for the variable x raised to the same power, 3. So you can combine those. Here we have another set of like terms. We have a minus 2x squared and a plus x. You can combine those. You get a minus x squared. Next, when you have a like term, same variable, raised to the same power, you can add and subtract them. You have 4x plus a negative 2x, so be a plus 2x. And the last one here, we have constant terms. We have a plus 3 and a plus 1, makes it a plus 4. For our final answer there. To subtract two polynomials, we make sure to get the negative sign in each term. So we end up using the distributive property. So imagine there's a 1 there, we distribute the negative over every term inside the polynomial. Okay, so we did that part first. I distribute the negative. Notice it changes it there. It's positive here. After I distribute, it becomes negative. It has changed the sign of everything inside. But after that's done, I can go ahead and identify my like terms. Here, x at 3x minus 2x is just x to the third. Here I have minus 2x and a minus 1x mixed with a minus 3x. Next one here is I have 4x plus 2x, which is 6x. Next one I have 3x plus 3 minus 1. Plus 3 minus 1 is going to be a plus 2. And that is our final answer in that case. The next concept is multiplying polynomials. When multiplying polynomials, you need to multiply each term in the first polynomial by each term in the second polynomial. Here, we're multiplying two binomials. You end up using a mnemonic to help us. It's called FOIL. You multiply the first terms, the outer terms, the inner terms, and the last terms. So let us take a look at this thing together. You see here, 3 times x, 3x squared. The outer terms, 3x times 4 is 12x. Then we have our inner terms, minus 2 and x is going to be a minus 2x. And our last term from both. And the last one here we have what? We have 2 times 4. Minus 2 times 4 is going to be a minus 8. Okay, so once we've gotten to this point, we can simplify our like terms, combine our like terms here. We end up with 3x squared plus 10x minus 8 for our final answer. You do not have two binomials. You need to make sure that each term in the first polynomial is multiplied to each term of the second polynomial, distributed completely. So here you have 2x times 3x squared. You see, it's always helpful to draw a line there. You got 2x times the minus 2 minus 4x squared. Outer terms. Here we have 2x times 4, which is 8x. And we have our last terms here. Here we have inner terms there. 3x squared times negative 3 gives me a negative 9x squared. Here we have negative 3 times a negative 2 is a plus 6. And here we have a negative 3 times the 4 is a minus 12. Now, what is important in this particular diagram here is that you can see how the arrows point to where everything has been multiplied to make sure that everything is being distributed completely and evenly. So this is the behavior you will want to model when you're multiplying and distributing. You want to make sure everything is getting distributed completely the first time. That is the end of this presentation. When you combine like terms, what do you end up with? So you shift it, you can add like terms here. 6x to the third minus 13x squared plus 14x minus 12. And that is your final answer there. Okay, and there's our final answer.